Hey guys, welcome to the video on modes of inheritance using a pedigree chart. So just to remind you, monohybrid, test cross, and sex linked are all about one allele being passed down. Okay, so when we talked about monohybrid, we talked about dominant and recessive genes. You can have a dominant gene that masks the recessive gene, and you will see that passed on, or you can have recessive genes that are needing one allele from each parent in order to be present. We're going to now take that idea and put it into a visual, and that is a pedigree chart. So in your notes, you're going to have to follow along. These are the tips and tricks on how to solve a pedigree chart. So we're going to talk about how to solve and how to figure it out. We're going to do lots of practice in these, so don't stress. The idea is you need to memorize this. I have no special way to do it other than you just got to know it. So write it in your notes, and we're, like I said, on Monday and Tuesday, we're going to be working through this quite a bit. So we're going to start by talking about a couple things here that have a couple different names. So as you can see here along the top, I have the names of the columns. Now, rather than freak out and be like, I don't know what some of this means, autosomal just means that they're not your gametes. X-linked means they're the sex-linked or the gametes. Okay, so autosomal recessive and autosomal dominant are examples of the monohybrid crosses we did at the beginning, and X-linked recessive and X-linked dominant would be examples of the sex-linked we've done. Y-linked is only passed through males. So when we talk about them, we are going to use the following different things. So here are the letters that are going to tell you if something is affected or unaffected. Affected means they have a disease. Unaffected means they do not have the disease. A carrier, again, is someone who's heterozygous that carries the allele for the disease but does not have the disease. All right. So again, write these down. So in autosomal recessive, in order to be affected or be sick, you have to be a, because that is the recessive form. Big A, or big A, little a means unaffected because, again, it is recessive. We need two little a's for that to work. So when we are solving a pedigree chart, we are going to put the following things in, and on Monday, we're going to work through these. So we're going to write these down. I'm going to kind of explain them as I go, but it's not going to make a ton of sense because we haven't actually done one. So in an autosomal recessive pedigree chart, you're going to see that it may skip generations. What that means is you may see an unaffected set of parents having an affected child. So that's what you see here. These mean mom and dad. So circle is female, square is male. Okay. White or not shaded in means unaffected. Shaded in means affected. So when I say it may skip a generation, you're seeing here two parents who are married. So that's what this lovely thing means right here. Two parents who are married do not have the disease, but their child has the disease. So that is skipping a generation. You also know it's autosomal recessive if you have two parents who are affected and all the children are affected. Why? Because both parents would only be carriers of the recessive allele. So both parents show the recessive allele. There's no other allele to donate. Both of them are only donating recessive alleles. All right. So autosomal recessive, again, is working on the concept that it's two little a's being passed on. Shaded in means affected. We're going to go through and look at these again here on Tuesday, so don't stress if the pictures are not quite making sense yet. In autosomal dominant, same idea, okay? We're looking not at anything connected to X's, but just simply big letters and little letters. So here we go. The difference between autosomal recessive and autosomal dominant is now, instead of having two little letters, meaning you're shaded in on the chart, you are now unaffected. And if you have a big letter at all, you carry the disease. In dominant linked pedigrees or in dominant linked anything, you cannot really be a carrier, because if you have a dominant gene, it presents itself if you have a big A or a little, any sort of A. So a big A and a little a would be showing the dominant gene and would be showing that you have the disease. So in this case, it does not skip generations. The picture before shows it skipping generations, okay? Same with this picture. It can't happen this time. Okay? If mom and dad are unshaded, that means they are unaffected, meaning they carry the little gene A and A. Those are the only options they can pass on. There's no big A option here. So mom and dad do not have a big A to have this happen. So in autosomal dominant, it does not skip generations. If you have an affected individual, you only need to have one affected parent, such as that. What this means is that mom has a dominant gene of big A, dad does not, but it doesn't matter because as long as mom passes that one affected gene on, some of her children will be affected. So that is autosomal dominant and autosomal recessive. We're now going to look at X-linked and in recessive and dominant. Now this time you're going to have to split it kind of at the top in half because we got to talk about it like this. Because as we know, X-linked means that we are looking at the gender chromosome. So 23, so an X and a Y. Okay. So boys in X-linked recessive, if they have the big letter, they're unaffected. And if they have the little letter, they're affected. And guys, this is no different than when we talked about the example of hemophilia or we talked about the example of color blindness. Okay. The way it's inherited is the same way. This means they don't have the disease. This means they have the disease. Same with the females. If you carry any large letter, you do not have the disease. If you carry both little h's, you have the disease. Again, women can be carriers in this case, but not males, because as you notice, you can't have a carrier. It's just one or the other. Again, like the autosomal recessive, you can see the skipping generations. So mom could be X big H, X little h, that's mom. And dad would be X big H and a Y. Mom donated the X little h to her son. Dad donated his Y, and that is why you would have a affected son. So you see the parents are not affected, but they could have an affected child. So again, that is called skipping a generation. Now this is where the tips and tricks are going to have to come in because you have to follow along exactly what it's saying. It's saying if a daughter has the disease, her father has to have it. Okay, so why? Well, because mom can be a carrier. She can be X big H, X little h. But dad only has two choices. He either has it or he doesn't. So if dad has it, then we know dad is passing on a little h to his daughter, and we know mom is passing on that little h to daughter. So she has the disease. She is affected. The reason why this daughter is not is because mom donated her large H and dad donated his small h. So it would be mom donated this one and dad donated this one. Okay, so you have to go kind of, in this case, backwards. You have to say, okay, this daughter has it. If this daughter has it, her father has to have it because she got one of both of her alleles from her dad. One of her affected alleles from dad. Both affected alleles came from her parents. Now, if a mother has it, all her sons are going to have it. Okay, so again, it has to be done in the exact order it's read. Okay, so if your mother has it, it means she has two recessive alleles, little h, little h. They're the only option she can pass on. So if a mother has it, all her sons have it. Okay, so again, reading X-linked recessive means you have to read it in the order it's given. If two parents are affected, then all children have to be affected. Again, that is no different than autosomal recessive. So again, when we're going through this and trying to memorize this chart, if you can remember autosomal recessive skips generations, and if all affected parents have affected children, if you can remember those, it applies to both. Then really all you have to do is memorize the two new ones, the middle ones, to decide if it's between an X-linked or an autosomal. And I'm gonna show you the tips and tricks on how to solve these next week. So an X-linked dominant, again, you can see very similar to autosomal dominant. Boys, again, affected and unaffected, just like recessive. And girls, again, have the same options, big H, big H, big H, little h, and then two little h's. But in this case, again, like autosomal dominant, we don't have a carrier. If you are this genotype right here, big H, little h, yes, you are a carrier of the disease because it's the dominant gene, so you present the disease. So there's no carrier, you just have the disease. So again, like in autosomal dominant, it does not skip a generation. If this is the parents, they're both this little h, and little h and y, there's no way we could get this son presenting with that disease. So this is not possible. It does not skip a generation. One of these parents would have to be affected if it was dominant. Okay, again, this is where the tip and tricks come in. You have to read it exactly as it is. It's kind of, if you look between X-linked dominant and X-linked recessive, they're going to be kind of flipped backwards. So this one says a daughter has it, her father has to have it. That means it's recessive. In this case, if the father has it, all his daughters have it. So in this one, we went daughter to dad, and we're like, oh, yeah, that makes sense. This one is dad to daughters. Okay, so an X-linked dominant, dad only passes on one dominant X. That means all his daughters will present with dominant X's. His son will not, because dad gives the Y. If mom also had the dominant gene, then her son would have it. All right, so like this one, it says if a mother has it, all her sons will have it. In this case, if a son has it, his mother also has to have it. So this one's backwards again. So this one was backwards to daughter and father. This one's backwards for son to daughter. And the reason is because mom could be affected, but she could be this genotype, X big H, X little h. And that's like in hemo, that's like, what's the disease I'm looking for? It'll come to me and I'll think of it in a minute. Anyways, mom is donating the large H down to her son, but she also has a small h in her genotype. She's this genotype right here. So if this son gets that, then he will have no disease. So that's why this one can't work mother down. It has to be son up. If he is affected, the only affected X he could get is from his mom. So in Y-linked, okay, Y-linked are only boys are affected. So in this one, the more likely chance is that it's carried on the Y chromosome. Again, it will not skip generations. It's fathers to sons. No girls in the pedigree will be affected, and it looks something like that. Okay? So what you need to do is you need to get all of this into your notes. So if you want to pause it and then just copy this all down, that would be amazing. Copy the pictures as well. The only thing I'm going to tell you that I don't have on here is when we're solving pedigrees, and I will say this out loud again, when we're solving pedigrees, just like we talked about with X-linked, in X-linked recessive and dominant searching for these pedigrees, most of the times we will know it's X-linked if more males compared to females have the disease. Because as we know, it's easier for males to get X-linked diseases than females because they only have the option of big H or little h. So, I did put it in here. Sorry, I fixed it. So more boys than girls are always affected. So when we solve these pedigrees, guys, that is one of the things we're going to talk about. So I'm going to just back it off here. Just as a reminder, get this in your notes. This is where we're starting. This is the cheat sheet we're using and doing a drawing quiz on. So please make sure you copy this exactly. I hope you have a great weekend. I'll see you on Monday.